Well, good morning or afternoon. As you may have noticed, I am not here today. Actually, I am. I snuck in and I'm hiding in the back corner. Now, the question is, how many of you turned your head and looked just now? Raise your hands. The question is, how many of you just raised your hands just now? Oh, okay. Well, proceeding on. What we're going to do is I'm going to go over a recap of yesterday's lesson and then move into the homework assignment that I gave you. So let's go ahead and get started. First thing we did was altitude. So altitude, again, is basically what you were used to a couple of years ago when we talked about height of a triangle. And when we look at this, and here's a nice good acute triangle right here, and we find the height by going from a vertex and making it perpendicular to the opposite side. We just go down here and find its height that way. Think of this as laying flat on the ground, and you have to find the absolute height from the top of the building to the flat part of the building, and the building kind of looks like this. So that is your height. Now we have 3 of these things per each thing because we can rotate. We say, well, wait a second. This is dimensional space. I could have rotated this thing and made this the bottom, so I would have found the height by going from here to here. So I could start at this vertex and go here. And it needs to be perpendicular, and that doesn't look very perpendicular to me, but close enough for government work. And then we would have another one over here, going perpendicular to this side over here. And it doesn't matter where this ends up. It could be sometimes the middle, it could be way off to the left, right, whatever. It's just measuring the height from the tippity top to the very bottom of the triangle. And this right here, this one exemplifies it the best. Here we have an obtuse triangle. And let's just say I want to find the vertex of this point. It's like standing on the very top of the building and dropping something, or say you have a string with a weight on the bottom of it, and you just kind of drop it and it goes straight down until it hits the bottom of the floor. Well, the bottom of the ground is right here, and you're just going to drop straight down, right angle symbol, because it's perpendicular, and you have your altitude for this obtuse triangle out of that vertex. Again, I have different altitudes, 3 per triangle. And here we have a right triangle. Our altitude can be here. When we did 1/2 base height a long time ago, this would be like 6 and that would be 4. We just do 1/2 base times height. But we can rotate the triangle like this, and this is a height. And we can rotate the triangle like this, and this is now flat on the ground. We have a pyramid type thing. And this would be the height. So we have 3 heights on our right triangle as well. So let's take a look at an example. Here we are given the measure of BDC. BDC is equal to 4x plus 30. So I'm going to write that in here. 4x plus 30, parentheses, angle sign. And BP is an altitude. Well, we know that BD, why did I put a P there? BD is an altitude. Well, we need to figure out what this length is. Well, in algebra, we would just solve for x, and that's exactly what we are. We're back in algebra. We would set this equal to something. Since it's an altitude, part of the definition is this is 90 degrees. So we'd have 4x plus 30 is equal to 90. 4x is equal to 60, and it looks like x is going to equal to 15. Right? Because 4 times 15 is 40 plus 20, which is 60. And all we would do is we take that 15 and plug it in here, we plug it in here, and find our geometry answer. So that's going to be 45 plus 1, it's going to be 46. And this is 50 plus 15, which is 75. And we would add these together. Alright, so moving on. Perpendicular bisector. This one's a little tricky, but it's not as bad as we would think. The first word you want to key on is bisector right here. And we want to find the midpoint, or how we want to bisect each one of these segments to find our perpendicular bisectors. Again, we're going to have 3, just like the altitudes. Well, I didn't write this out earlier, but I'm going to eyeball it and just proclaim this dot right here the bisector of BC. It may be a little off. Move that down a bit. And I'm going to bisect it. Well, I did that just now. I'm going to make a perpendicular line, because now we go back to the perpendicular part, make that 90 degrees, and I'm going to draw a line right through it. This is my perpendicular bisector. Voila. I bisected this line, and it is perpendicular. I can draw an infinite number of lines through here, but only one's going to be perpendicular. And I would do the same thing for the other sides. Now, we don't have too much that we do with this right at this instance in this course, but it is something that we're going to explore in depth when we start looking at some of the inside segments. So what we would do on an example right now is construct perpendicular bisectors for each one of these. And I have labeled my midpoints, because that's very important, because that's how you bisect it. And I'm going to go ahead and draw my bisectors. And I'm going to put 90 degrees right here because it's opposite reciprocal on the slopes. And I'll do this in green. And there's one. I'll rotate this. Just like that. There's the other one. And let's do my third. Completely missed, but close enough for government. Okay, so they're supposed to meet somewhere right around here. I didn't draw quite correct. All right. So moving on, median. All right, people at the door. So where was I? Medians. Yes, median means middle. Like when you're driving down the center of the road, you're taking a driver's test. Don't cross the median when you're not supposed to. That'd be a no-no. So what we're going to do is find the middle of the opposite side. And medians cut these sides in half. So here's a median right here. I'm going to eyeball it again. We should measure these by some way. We can construct medians by using our bisectors and so on. But I'm just going to eyeball it for time's sake. So there's my medians. I start with the midpoint, and I draw from my midpoint to my vertex, to the opposite side. And here I'm going to go to the opposite side, and here I'm going to go to the opposite side. And here they meet in the middle, which is the centroid. The centroid, as I mentioned, is very important in a lot of things, especially in aeronautics. We're talking about center of gravity, even ship loading, trains. There's a lot of things. Gymnasts, center of gravity is a big deal. But importantly, one of the things that I had experience with is center of gravity, of course, is on aircraft. And this point right here would be the centroid. So let's take a look at an example. If ABD is a median of triangle ABC, find AB. Well, median just means, based on definition, that these two are the same. We set them equal to each other. We have x plus 3 is equal to 2x minus 17. Subtract x on both sides, add 17, you get x is equal to 20. Plug it in to AB, which is right here. So 20 minus 7 is 13. And that's how we'd find that side. Next one, angle bisector. We've dealt with this one on a frequent basis in the past, so this is probably the one you're most familiar with. We're just bisecting the angle. Whatever this angle is, we're going to cut it in half. If this was 50, each side would be 25. Now to draw this, fairly simple. I just want to draw to where it bisects. These two things are the same. It has nothing to do with what this side is. This doesn't split this up in half or anything like this, just the angle itself. And when we do it to all, I'm going to split this one up. I'm going to split this one up. And when they cross, it's going to be the incenter. The incenter has something to do with how we inscribe circles. Again, this is going to be a later lesson. Let's take a look at this example. I am given what is in blue. I'm given that these two angles are such and such. It is an angle bisector, and we need to find angle A. Just equal them to each other. I'm not going to do all the math for you, but we'll go ahead and set this up as 4x minus 25 is equal to 3x plus 5. We're going to have x is equal to 30. I take that 30 and plug it in right here. So that's going to be 67. So we went over, for the basic special segments, We got to dive into them a little bit more because there's some very special properties about how you can construct the inside of the triangle based on this and do a lot of algebra on the inside. And I'm going to make some videos in a few days on those particular types of problems. But right now I just want you to get used to those 4 basics and start learning what the points of intersection or concurrency are. And one way to learn that is an odd peanut butter cup may contain apple butter instead. Altitude orthocenter right here. Perpendicular bisector and circumcenter, and median centroid angle bisector in center. So let's put that theory to a test. Peanut butter cup. Don't you wish you had this right now? But no food in class. Think there's apple butter in here? Peanut butter cup. Okay, I'll see you tomorrow. Work hard.